Sorry, I was having trouble getting that one thing off there, and I also understand that those clicking noises I make on my on my on my mouse down there are kind of loud. But anyway, here's one of the homework problems. But before we get into that, let me show you something that might be on an exam or a homework problem that you might have already had to do. Anyway, let's take a look at three charged shells, all right, or objects. Here's one with minus 2.0 microcoulombs of charge. Here's another one with positive 3.6 microcoulombs of charge. And here's another one with, let's say, negative 4.1 microcoulombs of charge. Now let's bring them together. We'll call this notes for this section. All right, now let's bring them all together. And we've got the negative 2 microcoulombs, positive 3.6 microcoulombs, and the negative 4.1 microcoulombs. Now they're all touching. Yeah. All right. So, well, they're all in here together. Okay. So let's put the 4.1 here, negative. All right. And it's negative. So let's put them all in here together. Now what happens is all the electrons start moving around. Let me make this bigger so you can see what the heck we're doing. All right, all the electrons start moving around and they hang out in here, and they distribute themselves evenly throughout here. So what's the net charge? What is the net charge? That's the first thing you calculate. What's the net charge here? Well, we've got negative 2 plus 3.6 plus negative 4.1. And I'm almost embarrassed, but I have to do it again. Negative 2 plus 3.6 minus 4.1. It's negative 2 points. So the net charge, Q, in the system is negative 2.5 microcoulombs. All right. Now, let's separate the charges out. Let's say this was A, this was B, and this was C. Let's put A over here, B over here, C over here. What's the charge on each one of these now? Well, since the charge distributed itself evenly throughout the system, then this would be negative 2.5 divided by 3, negative 2.5 divided by 3, and negative 2.5 divided by 3. And when you add them all up, you get the negative 2.5. So I wanted to make sure that you understood that. That was one of the things we didn't talk about this morning, but there was one, besides that and this and the quiz were the only two things from the lecture today that we were going to do. So now let's look at real quickly the next homework problem. Okay? I'll try and use a black pen. That didn't come out very well, did it? All right. So now, here's the homework. Two spherical objects separated by a distance 1.75 meters. So I got to get my R. 1.75 times 10 to the negative 3 meters. Or basically 1.75 millimeters apart, but they already did the meters for us. Each object acquires the same negative charge due to the addition of electrons. As a result, each object experiences an electrostatic force that has a magnitude of 1.7 times 10 to the negative 20 newtons. How many electrons did it take to produce the charge on one of the objects? Okay. So let me write down what the force is. It's a dinky force, dinky force, 1.27 times 10 to the negative 20 newtons that it created. So now we've got two like charges. All right, so let's take a look at what this looks like. All right, so here's the situation. And we've got to come up with N. Remember, Q is equal to NE. But the first thing we got to do is we got to figure out what Q is. How much of that negative charge did they get? All right, so here's what we've got. We've got this sphere, this thing, the force. This is the force on 1 caused by 2 is going that way. The force on 2 caused by 1 is going that way. They're equal in opposite directions. We just pick one of them. let's say the force of 1 on 2, and that is equal to, we'll put in the negative sign when we're done. Right now we're just going to work with the magnitude of that force. Okay? We'll just work with the magnitude. We're not worried about the direction. In Physics 250, they calculate based on the orientation and the x-axis and stuff like that, where the object is. We don't do that. We draw a picture and go, oh, okay, well, it's going in the negative direction. Then I would add that later. All right. But anyway, so, but we're not now. So, that's what we do. We draw a picture. But here's what we do. Now, F is equal to K. The force that this guy's feeling is F of Q1 times Q2. This is good old Coulomb's law over R squared. Now look. Looky. It's saying here, I put in the absolute value signs because we're going to add the direction later. But it said they acquired the equal charge. So Q1 equals Q2, which equals Q. So I'm just going to put F1 of 2 is equal to K, which is the K is equal to 8.99 times 10 to the 9th newtons, meters squared per coulomb squared, all right, times Q squared. I'll just drop the absolute value signs, divided by R squared. Now, solve for Q is what you would do. So solve for Q, and then once you get Q, you go, oh, okay. Well, then to get the answer, you go Q is equal to N times E. So you know this, and you know this. So you should be able to solve that without much trouble. All right, I'm going to go to the next problem in a new track.